Hello and welcome to Unit 12. All right, so this first section of Unit 12 is going to be all about an introduction to circles and arcs of circles. So today we're going to be talking about a central angle in a circle and the arc length that corresponds with that central angle. So first thing we're going to do is talk about a little vocabulary here. So the first word we're going to talk about, something of a circle, is an angle whose vertex is at the center of the circle. So that would be a central angle. Part of a circle measuring less than 180 degrees is called a minor arc. Oops, forgot the R. So a minor arc, an example of that would be AB right here. This arc right here, that would be less than 180 degrees because remember a full circle has 360 degrees. Half the circle would have 180. This is obviously less than 180 or less than half the circle, so that's a minor arc. Now a major arc would be more than half the circle or more than 180 degrees around the circle, and that's called a major arc, like I said. So like this blue part from A to D to B, that would be a major arc. And then this angle right here where C is, this angle right here is a central angle because C is in the center of the circle. So that's something you're going to want to know throughout this unit because we're going to talk about different types of angles. But for today, we're just talking about central angles. So an arc with endpoints that are a diameter of the circle. So that means it's a line that goes through the middle or through the center of the circle. It's called a semicircle because it just creates half of a circle, or you could call it 180 degrees. So another important piece of information for this unit is that the measure of a minor arc, so if I go back up here, the minor arc was this red part of the circle over here. And this arc, or the measure of this arc, is going to be the same as the angle ACB right there. That's what this is saying right here. The measure of the major arc is the same thing. So if this arc, this minor arc right here was 50 degrees, that means the central angle right here, ACB, so this angle right here, is also 50 degrees. This major arc right here, ADB, well, since the full circle is 360, and that minor arc was 50 degrees of the full circle, 360 minus 50 is 310, so that means the major arc would be 310 degrees like they have right there. So now we got some examples to do. So we need to identify the given arc as a major arc, minor arc, or semicircle, and then find the arc, or find the measure of the arc. So TQ, so from T to Q, so whenever it gives us two letters, we always go the shortest distance. So I don't want to go all the way around here. I want to go the shortest distance from T to Q. So as you can see, this central angle is 120 degrees, and this corresponds or intercepts this arc right here. So that means this is a 120 degree angle. Since it's less than 180 or less than half, that'd be a minor arc. QS, so I'll just erase this as I go, so it's easier for you to see. So QS, so again, whenever there's two letters, we go the shortest distance. So Q to S, and just a little tip, whenever there's two letters only in an arc, it's always going to be a minor arc. So from Q to S, it's this orange arc here. So this is 60, this is 80, this is 120, so we got to figure out what this is. So that means this is 120, this arc. That arc is 60, this arc is 80, so we got to figure out what this arc right here is. So remember, all around the circle is 360 degrees. So we used 80 of it right there. We used 120 of it right here. And we used 60 of it right here. So if I subtract 360, let me do this on my calculator real quick. Actually, I probably don't need a calculator, but I'm already doing it. So that would come out to 100. Whoops. So that means the arc from S to R is 100 degrees. So the central angle will also be 100 degrees. So now if I go from Q to S, 60 plus 100 is 160. So this would be 160 degrees. And like we said before, that's a minor arc. Number 3, TQR. So when it has 3 letters, you have to go in that order. So you go from T, and then you go around the circle till you get to Q. And then R has to be the last letter. Let me erase the orange here. So T to Q to R would be that arc right there. So this arc from T to Q is 120 because of the central angle, tells us. From Q to R, it's 60. So 120 plus 60. Oh, I skipped some, whoops. Oh well, I'll go back to that. So this would be a semicircle. That's not how you spell semicircle. So QRT, which I definitely skipped, I'll go back to that. Oops, did not mean to erase that. So that's 180. So Q to R, and then all the way around to T. So remember, this was 100 degrees. So you got 60, 100, and 80. So if you add all those together, you get 240, which means it's a major arc because it's bigger than 180 or bigger than half the circle. TS. So from T to S, so again, whenever there's 2 letters, just always go the shortest way. So it's always going to be a minor arc. Or it could be semicircle, I guess. Since this central angle right here is 80 degrees, and it intercepts this arc right here, this blue arc. So see how it's kind of like going out, forms this angle, and then intercepts this blue part. That means that blue part is 80 degrees. So it'll be a minor arc. And then finally our last one, RST. So R to S to T. So again, this is 100 because we already figured that out. So 100 plus 80 would be 180. So it's 180 degrees, and again, it's a semicircle. So semicircle just means half a circle. We're going to skip these next 2 examples and the pictures and go on to number 3. All right, so find the measure of arc CFD. So from C to F to D. So notice I didn't go this way because I have to go C, and then F has to be the second letter, and then D has to be the last. So I know this is 81, this is 135, but we got to figure out some of these other ones. So notice, let me use a different color here. We have a line here and a line here. Those form vertical angles. So this angle and this angle are vertical angles, so they have to be the same, and then same with these 2. So that means that from E to C, it has to be 135, because from F to B, it's also 135, and those are vertical angles. So if this part from E to D is 81, then adding 81 plus whatever the angle is from D to C has to equal 135. So 135 minus 81 will be 54. So that means this is 54 degrees. So then we can use that to figure out these 2 other missing ones. Let's use a different color so you can actually see this. So I know all the way around the circle it has to be 360. So we know that this is 135. This part is 81. Well, we could just use this whole part as 135 also. So 360 minus 135 minus 135, and it's 90. So that means these two angles that are missing still have to add up to 90, but we know they're the same. So if we have two angles that are the same, we can just divide them by 2. So each one of those has to be 45 degrees. So now we know what all the angles are. So now I can figure out the arc CFD, the arc length of CFD. So it's this purple arc that goes all around the circle except for this 54 degrees. So really, once we found this one, we could have stopped. We could have just done 360 minus 54 and got 306. Next one, we got to find EFC. So from E to F to C. So this piece of information is important right here. These two angles are the same. And again, we have some vertical angles. So I got a line and a line there that go all the way through and they intersect. So that means this and this are vertical angles, so they are congruent. So if this is 126, from C to E, that has to be 126 also. Since these two add up to 126 and they are the same, that means I can just do 126 divided by 2, and that will give me each individual angle, so 63 and 63. And there's the bell ringing in the background, nice. So I could use all that information to find these two missing angles like we did in the last one, but to save some time, I'm just going to get the answer because now I know this arc right here, this is the only part of the arc that is not shaded, and that's 126. So if I do 360 minus 126, that will tell me the orange arc. So that would be 234, I believe. So from E to F to C, it's 234 degrees. M to I to J, yeah, that's I. So that means MIJ, I'm trying to find this angle right here. So again, let's use that green color. We have two lines crossing each other. So we got some vertical angles. So since the arc length from J to K is 55, this central angle has to be 55. This is a vertical angle, so it will also be 55, which means this arc will be 55 degrees. So now I know these two green parts right here, these green arcs, are 55 and 55, so that adds up to 110. So that means the rest of the circle, if I do 360 minus 110, I get 250. So this arc and this arc has to add up to 250, but since these are vertical angles, these have to both be the same. So that means I can do 250 divided by 2, which is 125. So that means this angle is 125 and then 125. And this is the angle we were trying to find, so that's going to equal 125 degrees. The last one is similar, so WV, I'm trying to find this one. So I'll go through this quickly because I know it's been a long video so far. So notice that these two are the same, so this is also 5x plus 10. So if I added these two together to get this whole arc right here, that would be 10x plus 20. Notice that we have a line here and a line here crossing each other, so that means these two are vertical angles. So that means that 12x minus 2 has to be equal to 10x plus 20. So solve for x, I get 2x equals 22, so x equals 11. So let's use a different color here. So we got a semicircle going all around here. This is a semicircle. This is also a semicircle. So I know I have a lot of markings on here. But now I can find this angle right here, or this arc, because I know what x is. So 10 times 11 plus 20 is 110 plus 20, which is 130. So this angle is 130, this arc, this green arc. This all has to add up to 180 from W to T. So WV has to be 50 degrees. And that's going to be it for the notes.